This is in the introduction to section 6.7, part 1. And in part 1, what we're going to do is we're going to be able to classify polygons in a coordinate plane. Now, we've talked about all these different shapes and different characteristics that go with it. And what I want you to do, you don't have this on your note sheet. So somewhere on a blank page, you're going to need to write these down. Okay. So as we look at the characteristics of the different types of quadrilaterals, first, let's start with a rhombus. So how do I show that it's a rhombus? I know that four sides are congruent, but the biggest thing with a rhombus is that you need to show is that the diagonals are perpendicular. That's going to distinguish between a rhombus and a rectangle, or a rhombus and a parallelogram type. Okay, so a rectangle. Again, rectangle has four right angles, and the diagonals are congruent. So again, as you're looking at a rectangle, you're going to try and show, if you want to try and show that it's a rectangle, that the diagonals are congruent. That's the big part. A kite, you know the consecutive sides are congruent to each other, so if you can show that, then you can show that it's a kite. Trapezoid, it's got one pair of parallel sides, or if it's an isosceles trapezoid here, the legs would be congruent. And then finally is triangles. Now they're going to give you three different sets of triangles to look at. Okay, and they're going to ask you, is this triangle scalene, isosceles, or equilateral? Well, isosceles triangle has two sides that are congruent. An equilateral triangle has all sides that are congruent. And a scalene triangle is that no sides are congruent. So again, make sure you have this list in your notes of things, because you're going to use this list to show what shape it is essentially. Okay, so as we look here at the first page here, you can classify figures in the coordinate plane using slopes, or using formulas for slope, distance, and midpoint. Well, here's what each one of these does. The distance formula is used to determine that sides are congruent and that diagonals are congruent. So you're going to use the distance formula to show those two things. You're going to use the midpoint formula to show whether the diagonals bisect each other or the coordinates of the midpoint of a side. Most of the time you're going to be using to show that the diagonals bisect each other. And then you're going to use the slope formula to show that opposite sides are parallel, diagonals are perpendicular, and sides are perpendicular. So that's what you're going to use each one of these formulas as you're looking at this for. Okay, so it says here in the first example, is triangle ABC scalene, isosceles, or equilateral? Well, remember, scalene triangle is no sides congruent. The isosceles triangle is two sides congruent. Equilateral triangle is three sides congruent. So the first thing you're going to have to do is you're going to have to identify the points. So A is at the ordered pair 0, 1. B is at the ordered pair 4, 4, and C is at the ordered pair 7 and 0. So on the triangle problems, I need to figure out what's the length of AB, what's the length of BC, and what's the length of AC. I need to find the length of the three sides. In order to find length, again, as I go up and look at my list up here, how do I find how long a side may be to see if sides are congruent? Well, in this case, I'm going to be using the distance formula. So, as we use this and when we look at this here, for the distance formula for AB, this is going to be, the distance is going to be the square root of, in this case, we're going to take 4 minus 0, square it, and add that to 4 minus 1 squared, which is going to be the square root of 4 squared plus 3 squared, which is going to be the square root of 4 squared is 16, 3 squared is 9. When I add 16 and 9, I get 25. So this is going to be 5. AB has a length of 5. Okay, BC, again, going to use the distance formula here. So on the distance formula for BC, if I take 7 minus 4, square it, add that to 0 minus 4 squared, that's going to be 3 squared plus negative 4 squared. 3 squared is 9. Negative 4 squared is 16. 9 and 16 is 25. When I add those together, and the square root of 25 is 5. So I know right now I can eliminate a scalene triangle because I know I have at least two sides congruent. Well, let's find the last side, AC. So now if I take here AC, 7 minus 0 squared plus 0 minus 1 squared. You got to find the distance. This is going to be the square root of 7 squared plus negative 1 squared, which is going to be 7 squared is 49. Negative 1 squared is 1. So 49 and 1 is 50. The square root of 50, I can't break that down in terms of a perfect square. I know for sure it's not 5. So this here is the square root of 50. Well, what kind of shape is this? Scalene, isosceles, or equilateral? Well, this is an isosceles triangle simply because two sides are congruent. Okay? So these are the kind of things that you're going to be doing in your examples. Okay, so let's take a look here at this next one. It says, is parallelogram ABCD a rhombus? And explain. Well, in order for it to be a rhombus, one thing we know for sure is that the diagonal BD has to be perpendicular to the diagonal AC. In other words, for them to be perpendicular, how would I show that? Well, we just got done working on that with 3/8. In order for them to be perpendicular, the slopes must be opposite reciprocals of each other. So, I need to figure out what's the slope of BD. Well, line BD has the ordered pairs 0, 4 and 2, 1. AC has the ordered pairs -2, 0 and 4, 5. So I need to find the slope here. The slope of BD, so the slope is going to be, in this case, 4 minus 1 over 0 minus 2, which 4 minus 1 gives me 3, 0 minus 2 gives me -2. So this is -3/2 slope. Now I need to find the slope of AC. So the slope of AC is 0 minus 5 over -2 minus 4, which gives me -5 over -6, which gives me 5/6. Now, as you look at these two, are these two opposite reciprocals of each other? Well, no, they're not. So we know that the diagonals are not perpendicular. So then, therefore, we know that ABCD is not a rhombus because the diagonals are not perpendicular. Okay, so this concludes part 1 of section 6-7, okay, where we're talking about finding shapes in the coordinate plane and being able to prove them. Don't forget to complete your WSQ.